Okay, AP Physics 1. Today's video is going to be a little brief and it's going to be a little bit different. I'm not going to give it the full treatment because we're not really going to talk about physics right now as much as we're going to talk about a certain problem-solving technique called proportional reasoning. And for some of you, this is going to come very second nature and you're going to have very little difficulty with it. For others of you, that's going to be not quite the case, and that's why we're going to spend some time talking about it now. So proportional reasoning is a method of recognizing how changing specific variables in an equation can impact the final result of the equation and vice versa, but we don't want to use any values. And what we mean by that is, if I'm changing the variables on one side of an equation, because of the equal sign, I'm going to have to change what is going to result on the other side. But I don't want to have to put any specific numbers in to crank it out. I want to just be able to recognize it from the equation itself. Now, before we go into how exactly to do this, there's a few relationships we need to recognize. And the first of these is A is proportional to B. And specifically, this is a direct relationship, because what this is telling me is that as B increases, A also increases in a linear fashion. Now, you probably aren't real used to seeing this symbol here necessarily. This is the proportional to symbol. And really what it looks like is I have basically an infinity symbol here, but if I took this side and basically cut it off, that's what I'm resulted with. So basically I have the one side of it cut off. Now, I want to be real careful here and talk about what this means, because, for instance, we're used to seeing something as A is equal to B, but now we're saying something is proportional. And well, how exactly is that different? Well, if I'm going to go from a proportional sign to an equal sign, I'm going to have some sort of constant in here. I don't know what this might be, but I'm going to have some constant of proportionality that I have to multiply B by to get A, basically to get equal to A, to make my units the same, and also that basically takes that proportion into account. But we're not worried about that constant right now. I just want to recognize the relationship that these are both proportional to each other. The next relationship we're going to be able to know is that we have what is an inverse relationship, ultimately telling me that as B increases, A decreases, or in other words, that A is proportional to 1 over B. But we could also see slightly more complicated things like A is proportional to B squared, or we could say to the square of B. And lastly, we could have A is proportional to the square root of B. I'm going to go ahead and tell you now, a lot of the equations we work with are going to do many of these relationships combined, and we're going to have to recognize how exactly we can manipulate both sides even though we have multiple relationships going on. So let's look at an example. So this right here is an equation we're going to learn later this semester, but right now we don't really care about the physics underlying this equation. We just want to look at the equation itself and just look at what we can do to it. And let's go ahead and say, so this is F is equal to GMM over R squared, where we have big M and little m. And let's go ahead and say we had a problem, a proportional reasoning type problem that said if both little m and big M are doubled, what happens to F? Okay, so how exactly can I go about doing this? So I have this equation, F is equal to GMM over R squared. Even though you don't know this, I'm going to go ahead and let you know that G is actually a constant and R is not. But the thing is, for the purposes of this problem, we're not manipulating either one of them, so we can treat them both if they are constant. So instead of writing F is equal to GMM over R squared, I'm going to change this up a little bit, and I'm going to instead use a proportional sign, and I'm going to say when I do that, I'm going to say anything that's kept constant, which in this situation is G and R, I'm just going to treat like the number 1, because I just care about these relationships, not these relationships. So I'm going to have M over 1 squared. Okay, so I've got this here. So I've got F is proportional really now just to big M, little m. And I look, it's actually directly proportional to both of these. Now, some of you could probably already figure out the answer to this situation in your head. That's totally fine, but this is something that's going to always be a safe way of going about this for us. So let's go ahead and say right now, I'm going to change this up slightly. Let's go ahead and say that the current situation, I'm going to say is F1 is proportional to big M1, little m1. And the situation is now calling for, okay, let's say I have a new situation, f2, where this is proportional to double little m and double big M. So I'm going to say 2 big M, 1, and 2 little m, 1. And if I have this here, I'm going to say, all right, well, this would be proportional to, I can pull this 2 and this 2 out. Multiplication, I can just pull those out of the equation. So I'm going to have 2 times 2, big M1, little m1, which simplifies to 4, big M1, little m1. But if I look, big M1, little m1 was just f1, so this is proportional to 4, f1. And in fact, this is pretty much already solved. I could say, oh, so if both m and m are doubled, what happens to f? It becomes 4 times the size. At the new situation, f2 is going to be 4 times the size of f1. It increases by a factor of 4. And if I want to rewrite this equation with the equal sign, I would just stick g and m back in. So I could say, oh, so f will be equal to 4g big M little m over r squared, increases by a factor of 4. And that's what we want to be able to recognize here. Now, some of you could have easily done this in your head. You basically would have just looked at this and instead said, you know what, I think I got this. What I'm going to do is I'm going to say, all right, well, if I double, this one, I can say, okay, that's times 2. And if I double this one, that's times 2. So on this whole side, I've multiplied it by a total of 4, and there's an equal sign. So if I multiply this by 4, then I need to multiply this by 4. Done. That is totally fine, and I'm fine if you go about it in this manner, but I want to show you a more formulaic way in case you get stuck. So let's look at the same equation again, but let's change things up just a little bit. So rather than changing m and m, our question is now asking if r is tripled, what happens to f? Alright, so that means in this particular situation, we can treat g, big M, and little m as if they are constants, because they are not affecting this problem. So I can say f is proportional to, let's see, g, big M, little m, 1 times 1 times 1, over r squared. Meaning it is just proportional to 1 over r squared, which makes this look a lot less intimidating. Now, how exactly are we going to do this? Well, we could say, all right, we're going to triple r, and more than likely, you're going to be thinking, okay, well, if I have f1 is proportional to 1 over r1 squared, then I'm going to now change the situation, and I'm going to say f2 is proportional to 1 over, and you'll probably think, oh, okay, this is going to be 3 r1 squared. And you might be thinking, oh, okay, I'm already done. And what I've really done here, you could say, oh, okay, so this is basically, I could pull the 1/3 to the front, 1/3, 1 over r1 squared, which would just be 1/3 f1. And it's a very good chance you think we are done here. Close, but this is a very, very common mistake. Because what we need to be careful of here is this squared. Because if we look at the squared, what is being squared is r1. And if we triple r1, that means what's being squared is not just r1, but 3 times r1. And therefore, we need to square everything together. So instead of this is not correct. Instead of this, what we're going to say is, okay, f2 is proportional to 1 over, and let's put in parentheses, 3r1 squared. Because what's going to happen is I'm going to say, oh, this is equal to, for instance, 1 over 3 squared r1 squared. I square everything in the parentheses. If we do that, we're going to notice, oh, this ends up being proportional to 1 over 9, because 3 squared is 9, r1 squared, or that therefore we have 1/9 f1, because f1, remember, was 1 over r squared. And therefore, if I want to write this out as a full equation, I can say, oh, so if I triple, if I triple r, so if I do gmm over, 3r squared, what I'm really left with is 1/9 what we had originally. So this is really, I should say, this is the new situation, 1/9 what we had originally. I can stick all these back in because they're just the constants. But the key point I want to get across here is that this is very, very crucial. So whatever is happening to this variable, if I triple it, if I double it, halve it, fourth it, whatever, if it has an operation happening to it, like square or square root, that must apply both to the variable and to whatever we have changed it by in order for everything to be consistent. So let's look at one more situation where we're kind of going to do this somewhat in reverse, because rather than changing something just on the right and see what happens to the left, we're actually going to change multiple factors here, and we got to be able to do this both directions. So this is a new equation. Once again, it's an equation you're going to learn later this year, and it's u is equal to 1/2 kx squared. So my variables are u, k, and x, and this 1/2, we want to be real careful here. This 1/2, we're going to treat just like we always do a constant. It is part of the equation, so we can't just get rid of it. So when we're doing our proportionality, we can just treat it like 1. That's not going to be a big deal here. So the question is, if u has been doubled, if I've doubled u, and k was octupled, now that's pretty fancy speak, but basically we're just saying if we times that by 8, by what factor was x changed? So in other words, if I multiply k by 8 and it results in a u change of times 2, something must have happened to x as well, because times 8 and times 2 are not equal to each other. So let's go ahead and rewrite my equation here. I'm going to say u is proportional to, I'm going to say the 1/2 is just 1 kx squared, so proportional to kx squared. And now let me go ahead and stick these changes in. So I have, for instance, well, okay, let's go ahead and say this was, u1 is proportional to k1 x1 squared. And additionally, my new situation is going to be u2 is proportional to k2 x2 squared. But there's a few things I can stick in here already because we've already seen that it's been done. That ultimately this becomes what? This is going to be 2u1, because we've doubled this, is proportional to 8k1 x2 squared. And the question is, how does this relate to x1? That's what we need to figure out. Well, if I look, I've got a times 2 on the front over here. I have a times 8 on the front over there. And how can I make those two equal to each other? Well, I need to make the 8 be divided by 4. So if I divide the 4, in other words, if I have an 8 and some constant here of 1/4, 8 times 1/4 would give me 2, which would make exactly what we want. Well, how can I get 1/4 in front? We could say, all right, well, maybe it's proportional to 8k1, 1/4 x2 squared, 2u1. But if we look, this isn't exactly going to work. Because if I look at this, 1/4, this variable, or this action here, goes to both the variable and the constant. So I'm going to get 1/4 squared x2 squared. And what's 1/4 squared? That is 1/16. And if I have 1/16 times 8, that's going to end up with what? 1/16 times 8 would be 1/2, and that does not match 2. So there's a problem there. So instead, what can I square to give me 1/4? And the answer would be 1/2. That 1/2 squared is a 4th. So I'm going to rewrite it again. Let's try this again. So let's say we have 2u1 is proportional to 8k1. And then this is going to be 1/2 x2 squared. And let's go ahead and double check this. So if I have 1/2 squared, that would be 1/4. I'm going to pull that in front. I have 8, so I'm going to also pull that in front. So I have 8 times 1/4 k1 x, this is going to be, sorry, this should be x1, not x2. x1 squared is proportional to 2u1. 8 times 1/4 is 2. 2 matches 2. There we go. So this was a more convoluted problem, and we want to be real careful that, while we're changing things, we're not going crazy with it. In particular, we want to make sure that we keep this 1/2 there. So if I was going to write this as an equals, I would say 2u is equal to 1/2 8k, and then it would be what? 1/2 x squared. That would be a proper way to write the entire thing, moving from the proportional to the equal sign, because that 1/2 is a constant we must keep in there. Okay, so this was a little more complicated. We basically were using both sides at the same time, and we're going to see certain situations like this. If you can handle this, and some situations that are just going slightly further, you're going to be perfectly fine. So let's go ahead and stop there. We'll talk next time.